All right, everyone. Everyone happy? Doing great, right? JK. It's a Thursday night. Just make it Friday already. Welcome to Studio Review. Today it is 12.8 Studio for Objects and Math. As always, got to start out with a question. Anything in particular you all want me to focus on in detail? All of it. Oh, wow. All right. Well, get ready for a midnight code review. This is going to be fun. All right, anything else besides all of it and me not being able to talk right now? Anything else you want me to focus on in particularly?
I think maybe I struggled with the random, like creating that random draw from the first little activity. I kept getting like repeater numbers, and I think I wasn't supposed to get any in the array that ended up printing out. So I'm curious if I was doing something wrong on that.
Yeah, I got that same thing, and I wasn't able to fix it.
All right, sounds good. Well, let's go ahead and do this thing. All right. Whew. Deep breaths, deep breaths. I wish I got a snack. I was really thinking about picking up cookies while I was out. All right, 12.8 Studio Objects and Math. In the exercises, you created objects to store data about candidates for our animal astronaut corpse. Yeah, I don't know why I always mess up on that word. For this studio, we provide you with a ready-made set of cadets. All right, cool. You must create code to A, select the crew, B, perform critical mission calculations, and C, determine the fuel required for launch. Sounds good. Let's see how to do that. 12.8.1, select the crew. Access the code for exercise 1. Open the Replit link. Sounds good. I'm going to go ahead and click on that link. The top right, we click for as always, and it's going to make a copy inside of my account. Awesome. There we go.
Quick question.
Yeah.
Dot floor is where it rounds down, and dot round is where it rounds up.
Floor is basically like truncating. Floor disregards any of the decimals whatsoever and makes it a whole number. So 8.99999, flooring that is 8.
Okay.
Oh.
Okay.
So it just erases the decimals no matter what.
Exactly.
Okay.
Isn't that what trunk does too?
I'm sorry?
Trunk does something different, but I can't understand what trunk does. Something with rounding up or
It
down?
removes the decimals?
To truncate?
Yeah.
Truncate will also remove the decimals. To floor it, I believe it will round it to the first whole number. So let me make sure here.
Like trunk would be like 8.99. It would just be like 899.
Let me actually, I'm going to do this from my own understanding too, just real quick, because I always forget. I believe console math.floor 99.9999. Yeah.
You had it right from what the methods say in the descriptions.
That's right.
That trunk removes any decimals and returns integer, and then floor just rounds it down to the lowest integer.
Yeah. So is there, okay. So, yeah, it doesn't sound like there's too much of a difference then. Yeah, okay. There has to be a difference too. So I got to find the correct example for that.
I could be wrong, but how I understood it was like floor actually rounds it to the whole number. Like not rounds it like up or down, but just takes off the decimal and stores it as that. But like truncate will just not show it. Is that the correct way to think about it, or am I wrong?
I believe truncate will still, to truncate a decimal means to dismiss all of the decimals, basically. It means to floor it. And what we're going to do here is we're actually going to just do difference between trunk and floor JS for JavaScript here. There we go. There's always a Stacked Overflow article on it somehow. Okay, so what I just did here, this is Kyle Wisdom coming in right now. I see that this is the question. I know Google found this question, so I already automatically just scroll past the question. Typically, I come right down here to the first answer. The first answer by the community standards is usually voted to the top, just like kind of like Reddit is. All right. There's much more. Just use truncate. Okay, they're conceptually very different. All right, let me see here. Truncate 3, round, yeah, 4, floor 3. Okay, so it always comes into negative numbers, it looks like. So for a truncate on a negative 1.4 is a negative 3, and a floor on a negative number is a negative 4. So it looks like it only matters with negative numbers between your truncates and your floors.
Okay.
So that's where it will start coming in. So if you floor a negative number, it's going to go down to the lower negative number. So it looks like it takes the, if you want to call it the worst case scenario, the lower number of the case. While truncate literally just removes the decimals.
So floor rounds down and round rounds up, and truncate just takes it away.
Round rounds by rounding convention.
Right. Round will just round normally. Truncate will truly just remove the decimals, no questions asked. Floor will bring it down to the lesser integer. So if we have a negative 3.14, it will floor it to negative 4.
Yeah.
So that's the difference there. So it looks like we just want to remove decimals. On the randomizer, we don't really care because we're going to be dealing with positive numbers here. But this is the true difference between truncate and flooring, it looks like. Fun question. We're not even on like a question yet for the studio, and we are getting some good stuff. So this is awesome. All right, any other questions on this? All right, let's get into this thing then. Great question to start this off. All right, and with that question, we are done officially with 12.8.1 first portion. Now on to 12.8.1.1, randomly select ID numbers. Each candidate was assigned an ID number, which is stored in the candidate's data file and in the ID numbers array. Write a selected random entry function to select a random entry from the ID numbers array. Review the combining math methods section if you need a reminder on how to do this. All right, before we read any further, I'm going to go over here to the replit and see what we have to work with. Okay, code your select random entry function here. And then we haven't talked about that just yet. All right, looking at it, cool. So to function to select a random entry from the ID numbers array. All right. I'm just going to grab that real quick because that is our goal. I'm going to put a comment in there, and we're going to start writing this function. So it says we need to create a select random entry function here. So to start creating my function, I always use the keyword function, and then I say select random entry, just like that. For right now, I'm not going to put any parameters in there and just put our curly brackets in there now. So we have fully set up our function here. Perfect. All right, so as we learned in class, to select a random entry, we need two different parameters or two different variables. Those two are the min and the max. Essentially what number we want to start with and end with. In class, our example was 1 through 10. Our min and our max, our min in that case would be 1 and our max would be 10. So in this case, I'm going to say min, max for our parameters. That's what we want to provide to the function. Next, we actually want to do the randomizer function. The randomizer function was also provided in lecture here. It's also, I believe, provided in the reading material. Can anyone confirm that? Just want to make sure. I believe the function is in there somewhere.
Yes.
Yeah.
All right. Do you guys have a chapter number by any chance on?
12.6.
12.6. Let's go ahead and find it there. So 12, we're going to go down to 12.6. We'll use exactly the one that launch code wants, and it is right here. So This is the random selection. Perfect. All right, so I'm going to copy this. We're going to have to make a few adjustments here, possibly. Oh, you know what? We will not. We will not. We're actually going to copy this entire thing because we're going to be provided an array. So if we come over here to the replit, so code your selected random entry function to select a random entry from the ID numbers array. As we just saw in that example, it takes in an array. So we're actually going to utilize that function that's provided in launch code a little bit more closely. So what I'm going to do is change the name here. We're going to keep array, and we're actually going to keep its functionality just the same. So what I just did is basically very closely reference my reading material in 12.6. Thank you very much for that chapter. And this is what we come up with. So this is the select random entry we got from the launch code. So we really didn't do too much coding on our end. We just utilized reading we did previously. So any questions on this one? Real quick, just to go over what this actually is and why this looks a little different from our example in lecture. We start with the math.random here, and we multiply it by array.length. Remember, in the lecture class, and I wish I still had that replit open, is that we had to subtract it by the minimum number, and then add the minimum number back after we did that. So if we look at this, this was the original. I'm going to close up a few things so we actually see it all in one line. This was the actual original expression that we were using. Now ask yourself, what is the minimum number of any array? What does an array size start at?
0.
0. So if these were 0 in here, if we remember our algebra back in the day, if we just have zeros in an expression, we can technically just erase them. Hence why our function looks a little bit different than what we did in lecture, because we don't technically really have a true minimum. Our minimum is 0. Hence we just remove it out of the expression.
Okay.
Fun math stuff, right? All right. Any questions on that one? All right, let's go ahead and test this. Real quick, what I want to do is, okay, where's our ID numbers here? I want to console log just a random number. So I'm going to say select random entry, the ID numbers. I'm passing in the array there as the parameter. Do that. I'm going to run this. And 796. Let's hope there is, oh, there it is. It's right there. Let's go and run it again. 890. Perfect. One more time. 414. All right. Looks like we are getting some random numbers back that are all within that ID numbers array. So we are doing A-OK. Yes, that rhymed. Hilarious. Any questions on that? All right. Let's keep going then. On to number 2. Call the function 3 times to select 3 ID numbers. Store these selections in a new array. Make sure to avoid repeating numbers. No animal can be selected more than once. Okay, so it looks like from this line here, call the function 3 times. It doesn't say to create a new function, so I just want to double check that. Is this, okay, one second. I see this comment in here. I'm seeing if it's indicating that we need to create this function to build the array, but I didn't see it to say to do that. Okay, no, that's down in there in the second portion, so we're good. All right, let's go ahead and do that. What we need to do is call the function 3 times, select 3 IDs, store these in selections in a new array to make sure to avoid repeating numbers. No animals can once. All right, sounds good. First things first, it sounds like I need to remember my IDs while I'm looping through all this. So I need something to remember these numbers, aka an array. If I need to remember something at any time in my code, I need to create a variable. So I'm gonna say let selected numbers. I'm just gonna come up with an arbitrary name there, selected numbers equals an empty array because I have not selected any numbers just yet. I need something, again, to remember these IDs. Awesome. Now, here comes the fun part. What kind of tool should we do to loop through this?
A for.
Typically,
No,
if we were,
is.
We could do a while loop.
We did while loop.
I like the while loop option. So let's talk about why we chose the while loop instead of the for loop here. For loops are typically to loop over an array, to read it, to do something, whatever. But we're not technically looping over an array. We're doing something to build a new array. And we need to keep building this array as long as the condition is not met. That condition being the selected number array does not equal 3. We need 3 unique IDs inside of this thing for us to meet that condition to stop looping. Because the question is the array filled with 3 unique numbers? Is it conditional? That's the question. That's the thing we're actually trying to do here. Because it's a question, we typically want to approach this question or build something like that with a conditional. So that being said, yes, we want to do a while loop. So that while loop is going to look like while selected number dot length is less than 3, then keep on looping. So this one is a little bit tricky. Though we are working with arrays, we are technically not looping over a single array. We can't do array.length on anything here. We need to keep building while a condition is not met, hence indicating that while loop. All right. So what we need to do now is we need to say const selected. Oh, let me put this here. Selected numbers, plural. I'm going to say selected number, singular here. Select random entry. ID numbers. All right. So here we are going to select the random entry. Now for this one, it would be, if you are doing the while loop, it would be very, very, the word is lost on me. I told you I am absolutely brain dead today. I completely apologize. But it'd be, oh, there it is. Very tempting. Like the word comes back around right there. It would be very tempting to do selected numbers, again, dot push, and put in the selected number from that function there. And then we would console log the selected numbers.
I think your while statement needs to have a selected numbers, right?
It does. Thank you very much for that. Yes, absolutely. That's the hard thing about having two variables very, very closely named the same. Yes, thank you very much. Selected numbers. This one is relating to this array up here. So perfect. Let's go and see what happens. Look at our first result back. Thank you. I was like wondering if it was going to be really random. So I was going to see if this is actually going to work. What is wrong with that array? We ran it. It has three things, but we are missing one condition. What is that?
Duplicate.
I think I heard it. They are not unique. So we have two 599s in there. That is not what the question asked. We needed these all to be unique. So what I need to do is validate to make sure that the number that I selected there on line 20 does not already exist inside of the selected numbers array. Now, if I need to validate something or check something, what kind of tool do I typically use?
If.
Very good, an if statement. If statements check something. They validate stuff. So I need to include an if statement here. So I'm going to say if selected numbers, again, plural, dot includes the selected number. Well, I'm going to say it, my condition will be wrong here. If equals false, then I want to push that selected number into the array. Now, another way to do this again, say equals to false, is actually take out this portion right here and shorthand it by putting the exclamation point on the far left there. So this is a way we can validate to see if that number is already in the selected numbers array. So let's go and try this again. Press run. And we're getting a lot better results here. Look at that. I'm not seeing any copied numbers as I run through this. All right, so I'm going to pause here. Any questions on this? Anything at all? All right. If there's no other questions, I'm going to keep going then. So this is how we wrote our while loop. One more thing I want to show you with one extra little keyword, if anybody was interested. If we wanted to say if the select numbers dot includes instead, we want to just do the true statement here. Another keyword we can do is say, okay, at this if statement on line 21, if this is true, I don't want you to do anything else below my code. A keyword we can introduce here to just say, hey, stop here and go back up to the top is a word called continue. Continue means stop here and repeat the loop. So basically it says at line 22, if this is executed in line 22, it says immediately go back up to line 19 and see if you can loop again. That is what the keyword continue means. This is another approach you could have taken if you wanted to with the while loop. You can do continue in any loops actually, including the for loop. If we run this again, we see we get the same exact results, no copied numbers inside this array. Now, if you're asking yourself also, okay, Kyle, with this approach, we're getting a bunch of extra loops in there. You're absolutely right. This is a random this is a random number generator. We have no idea what it's actually going to produce. So if it does hit the same number a few times, we're going to have to loop through until it gets it right. This is a common practice in here if we have to deal with something so volatile, again, such as a random number generator. So this is not out of the ordinary to see a while loop used like this. All right, let's go ahead and keep going and see what else we have to do with. So we just finished
Wait, I'm sorry.
Yeah, Joseph.
So when I do it, I get something that says circular. I'm not sure what I've done wrong.
So an infinite loop.
So it gives me two numbers. It says circular after each one. I'm not sure what I missed because my text looks the same as yours to my immediate eye.
Okay, can you go ahead and
continue? I didn't put the continue in yet, but.
Okay, can you go and, is that an error that you're getting?
No, it's printing very odd. I don't know.
Can you go and paste your code, direct message me your code, and I can take a quick look and see if there's anything.
This is everything between the two comments. That it's
okay. All right, so while you're doing that here, we are done with 12.8.1.1.
Really
what was that?
Should I send that on Slack? I'm bad at Zoom.
Yeah, go ahead and do it on Slack. So actually what you can do is type in 3 backticks and then paste it inside of the box that appears within that chat bubble.
On Zoom?
Nope, on Slack. So if we're here in Slack, we see here that I'm just here in announcements. If you do, actually, this is for everyone here. If you ever want to send code over and you don't like how Slack typically formats it, Slack was actually built for developers. What you want to do is place 3 backticks, and what happens is a black bubble appears, or depending on white, depending on what your settings are. And in here, you can actually place code that's actually properly formatted. So just letting anybody know that if you ever do need to share that. So 3 backticks.
That's cool. I was wondering how people did that. Yeah.
Yeah, absolutely.
Can I send you the code that you just typed in that I also typed in, because it's telling me that selected numbers isn't defined, if you can look at it later.
I can take the quickest look at it real quick. I would say double check on Joseph. You have 2 lines that say push on there. You're gonna have to choose which one you actually want to push.
Oh, that's what I was missing. Okay. So I need to take the push off the second line. That's what you had? Or did you have?
All right. So I can definitely take a look at it, and you feel free to send it over to me. If we have time in the end, we'll just go through it. Or if I have just a quick pause, I'll definitely take a look at it. All right, we're going to move on here to 12.8.1.2. Build a crew array. Design a function that takes 2 arrays as parameters. These hold the randomly selected ID numbers and the candidate objects. Use 1 or more loops to check which animal holds the lucky ID number. They will be going on the space mission. Oh, so fun. So store these animals in a crew array and then return that array. Use a template literal to print blah, blah, and blah are going to space. Fill in the blanks with the names of the selected animals. Sounds good. All right. So what we need to do is design that function that takes in 2 arrays as parameters. So they hold the randomly selected IDs and the candidate objects. So let's go ahead and start by doing that. Excuse me. All right. What I'm going to do actually is move this up here below that. We're going to start building our crew array. So I say function build crew array. It says it takes in 2 different parameters. The first one being the selected IDs, and the second one are the candidates. There we go. All right. So it says that we need to then, let's see what we're going to do next. It says the next thing is use 1 or more loops to check which animals hold the lucky ID numbers. They will be going on the space mission. Store these animals in a crew array and then return that array. I'm going to go ahead and copy that just so I have that to look at when I go back over here to the replit. All right. So we need to go ahead and start building an array with the selected candidates. We have the selected IDs, but now we need to match them up with candidates. But I first need an array to hold those candidates whenever I find them. So what I'm going to say is let selected candidates, there we go, equals empty array. So now I have something to actually hold them, again, whenever I find them. So perfect. Now, what I need to do is search for each of those candidates. For this one, I'm going to loop over each of the candidates and see if their ID exists in the selected IDs array. If I need to loop over a set of things in an array, what kind of tool do I use?
4.
Very good. We're looping over an array this time. We don't have any condition to really meet. We could technically use a while loop, but in this case, it's going to just be easier if we just do a for loop. I less than candidates dot length I plus plus. Perfect. All right, we're able to loop over each candidate now. Awesome. What I'm going to do is going to console log now the candidate, just to see what I have to work with here. What I'm going to do is that I'm actually going to, oh, maybe, you know what? I should put this back down there. I'm sorry, I'm just moving this thing up and down all the time. What I'm going to do is actually keep all my functions together and put this below here. And now what I'm going to do is call to this function down here, the build crew array. So I'm going to say build crew array. Maybe not even down there. Oh my gosh, I have to put it all the way down there. Why am I putting, okay, so originally I was saying, okay, let's put it here because all I have to do is type in selected numbers, but I still need the candidates. But the candidates array is not defined up here. We go sequentially. Where's the candidates array defined? All the way down here. So I got to paste it down here. And candidates actually not called candidates here, it's animals. So I'm going to switch out candidates for animals. All right, so any questions on that? Why I had to place it all the way down here? It's because all the information was presented down here, so I need that information, and so the function needs to be called here. So I'm gonna go ahead and run this. What I should do is print out, oh, candidate is not defined. Probably named something wrong here. Oh, I misnamed. So what I did is I noticed that it's line 16. I come to line 16, it says candidate is not defined. Absolutely correct, it's candidates, plural. Apparently I'm having problems with my plurals today as well. There we go. Now we're actually getting some good stuff here. We see that we have all of our candidates lined up. We're printing them line by line, again, from this console log here on line 16. So cool. This means we're getting our information back from our array. Awesome. The next step is now to find the ones we actually want to select. If I want to check to see if something is equal and then do something about it, what kind of tool should I use there?
If.
Very good. If I need to check to see if something is true. I need to check to see if my candidate has the ID that is within the selected IDs array that is provided up here in the parameters. So very good. So I'm going to say if selected IDs dot contains, oh, that includes, excuse me, includes candidates, there we go, candidates I. Oh, okay, here we're having an issue. So I say candidates I, that means this thing, but what do I need to specifically get out of there to check to see if my selected IDs include
Isn't it supposed to be animals, not candidates?
Candidates is actually what I have in my parameter. We can call it animals if we wanted to, but this is up to the developer to whatever they want to name the parameter. But you are correct. Down here, it is animals. I pass in animals, and up here, it goes by another name.
Okay.
Candidates. But if it's easier for you, you can use animals up here and just keep everything just uniform like that.
Okay.
So down here, we have our candidates, but we don't want to see if a candidate's included, it is included in the selected IDs. We want to see what specifically in the candidate if it's in the selected IDs array.
Astronaut ID.
Very good. How do we actually call it to the astronaut ID?
Dot astronaut ID.
Very good. We use that dot notation. Very good. Yes, we say astronaut ID. Perfect. All right. If it is included in there, what we want to do is now capture that candidate inside of our selected candidates array. So we say selected candidates dot push. And then I put the candidate in there. Of course, it's that candidate, or excuse me, candidates at index I. So awesome.
Name. Isn't it the
For
name?
this one, let's go ahead and see. We're going to space system store the animals in the crew array. It says store the animals in the crew array, not the names. So in this one, we want to put the whole animal inside of there, it looks like, and then return that array. So if it said the candidate's name, I absolutely agree with you. But right now, it's just telling us we want to capture the whole thing, whole shebang, the whole candidate. So I'm going to actually capture the whole object there. Does that make sense?
Mm-hmm.
Okay. All right. So the final thing it said again was return that array, which is selected candidates. That's what I put there. Awesome. All right. So I'm going to come down here. This function, again, like we just set up here, returns something now. Returns the selected candidates. So where it's called, I want to get something back. I want to remember what it returns. So I say const selected animals, or whatever you want to call it. This is, again, just an arbitrarily named variable that we're creating. So we get the selected animals back, and what I'm going to do is console log those animals now. And let's see what we get. Go ahead and run this. It looks like we are getting back an array with these three things, but we are getting a weird thing up here. Why am I getting that?
Just clear your console and do it again.
Is that what it is? Thank you. I was like, that's weird. Oh, good old replit. Yes, all right, good. We are getting back our three objects there. So inside the array, we have the three objects. I don't even want to try that. Gordon Shumway, we have Lassie and Jonesy. Perfect. Oh, look at that, we got a cat, cool. So we have our three arbitrarily chosen or randomly chosen candidates here in this array. So we are well on our way of doing that printout. Any questions up until this point? I'll go and scroll back up to that for loop. Any questions? All right, and we're gonna keep going here. I believe the last thing it wanted us to do, I'm gonna go back over here to the studio, is use a temperate literal to print out a message, fill in the blanks with the names of the selected animals. All right, we're gonna do that. As you see, I just copied that again. I'm gonna be doing that quite a bit as we move through these more complex studios when we learn more stuff, just because I don't like to flip them back and forth, and my memory is one of a goldfish. So therefore, I need this stuff here. All right, use the temperate literal to print out that message. So what I'm gonna do is say const message equals temperate literal. What character do we start to create a temperate literal?
Backtick. Backtick.
The backtick, very good, absolutely right. And it says blank, blank, and blank, so I gotta fill in those blanks. To start putting information inside of a temperate literal, what do I need to start with? What character?
Dollar.
The dollar sign, absolutely. Cha-ching, we got it. What comes next?
Curly braces.
Curly brackets, open and close curly brackets. Fantastic. All right. So now we are able to put in information. The information I want to put in is selected animals from line 89 there. And we want to put in our first animal that was selected, the captain of the crew. And so I say index 0. And now I want to get the information out of that candidate. I want to get the name. To do that, or to get the name, what do I do? What do I put?
Dot name.
Dot name.
Very good. Dot name. Awesome. So it says that, comma, dollar sign, curly bracket, because we know how to insert information. Selected animals of the first index. Dot name. Then comma and dollar sign, curly brackets. Selected animals of soup. Dot name. Close that curly bracket. Are going to space, exclamation point. Perfect. What I'm gonna do is take that console log on line 90, get rid of that, bring it down here, and go and paste in message. Perfect. All right, y'all ready to see if this works?
Yes.
All right, let's do it. Let's run this thing. It looks like Gordon, Shermway, Lassie, and Pete are going to space this time. Awesome. Let's run it again. Wow, they love Gordon Shermway. There we go. Now we got a different one. Lassie, Jonesy, and Petey are going to space. So it looks like from these messages that we're definitely getting randomized results, which is exactly what we're looking for here to complete this challenge. So from this, we did a lot of stuff. We did functionalizing, we did some random number generation, we did some while loops, we did for loops. Any questions on any of that material we just went over?
Could you show me where you declared selected numbers?
Selected numbers. Selected numbers was declared right here on line 29 and utilized.
Okay, so it is global.
It is, yes.
Okay, cool.
Yeah, for this one, they didn't tell us to put in a function, which I was surprised about. So I just put it there, but yep, it is definitely global. All right, any other questions?
Is there no way to write that while loop without continue? Because I'm not familiar with that. And we tried it in the studio, but we couldn't. In a small group, we couldn't.
Yeah, so this is the original approach. The original approach, if we want to take out continue, was placing that code inside of there and then placing the not operator in the front of that conditional. This was the original approach. The continue is just to show an alternative to this. Does that help out, Hannah?
Yes, thank you, Kyle.
Yep, absolutely. All right, any other questions?
Could you show where you called build crew array?
Build crew array. So what we had to do was call build crew array after the candidates or animals array was created. So we had to call it at the very, very bottom here. Build crew array was called here. So where select numbers was accessible as well as animals. So as always, we move sequentially down. And animals was not accessible until line 86. All right, any other questions? All righty.
I'm just gonna, I have one last question, I'm sorry. Selected numbers, you did it slightly different. I'm just trying to follow. Selected numbers, where did you declare that or initially declare that?
The selected numbers.
Okay, and then you just, okay, cool.
Yep, select numbers was up here, and then we did a while loop to actually prepare that array with 3 unique numbers.
Okay, cool. Thank you.
Absolutely. Any final questions here? Anything at all? Oh, put that comment up here. All right, no other questions. Let's keep on keeping on.
Sorry, can you show the beginning? There's something I must have missed somewhere.
No worries. I can freeze on here for just a second if you want. I hear sometimes people take pictures of it. Feel free to do that. There's always the recordings too.
Okay, I should be good, I hope.
Okay, no worries. I always love the picture sound. No, absolutely. I love the picture sounds in the background. I feel famous. I was like, oh, take a picture all you want. It's my best work yet. All right, awesome, awesome. Let's keep on going here. We got 12.8.2 orbit calculations. This one tripped me up so much last lecture. So let's go and see if I can hopefully make up for it this time. To access the code for the orbit calculations and the first bonus mission, go to Replit. All right, that's what we're going to go ahead and do here. Go to Replit, top right, click fork. Awesome. All right. Well, that is forking over there too. We're going to go and see what we need to do. So number 1, spacecraft orbits are not circular, but we will assume that our mission is special. The animals will achieve a circular orbit with an altitude of 2,000 kilometers. And then we have A through D. Hopefully they put those in the replit so we don't have to read all of that. So let's go and see this. All right, code your orbit circumference function here. Apparently it does not tell us all those details. Excuse me. So define a function that returns the circumference, c equals 2 pi r, of the orbit around the circumference to an integer. All right, that's what we're going to do. So I copy that by just doing Control-C, place what we need to do here, and start writing our function. So we start writing our function by using the keyword function. And then we say orbit circumference, if I can spell that right. There we go. Open and close curly brackets. Awesome. So it looks like to get the circumference, it's C equals 2 pi r. Now, fun things. Who knows all infinite digits of pi? Anybody? Anybody at all?
Nobody. No,
Dang it.
3.1415957.
Hey, no, better than me. All I remember is, till 14, 15, and then I'm done. 3.1415, that's it. That's all I ever got. But luckily, there is a thing in the computer that always remembers it, and we're going to be using that today. So first, we need to do the circumference. Circumference, again, equals 2 pi r. So 2 is 2. Then we multiply it by pi, and pi comes in from the math library. Say math.pi. That is a property in the math object, which is great. And then we also need to multiply it by r radius. We don't actually know r. R has to be provided to us. So if it needs to be provided to us, it needs to be a parameter. So we say a radius in the parameters. Just like that. So that is how we can do our orbit circumference function. I'll leave that there just for note's sake. Any questions on this one?
That's literally it.
That is literally it. Pinky promise. That is it. But to answer the questions, so why did I know that exactly? Orbit circumference. It says it wants the circumference returned. It gave us that equation. C equals 2 pi r. I know that 2 is 2. Pi was the tricky one. Where's pi actually located? I knew pi was in the math object just because I'm familiar with the math object. That one could be found through the documentation, but it is a little bit trickier. So we say math.pi there to get that property out. And then r is radius. I believe it defines on r is radius. Maybe it doesn't tell us that exactly, but r is radius. Radius, I have no idea what it is. If I don't know what something is in the equation, I'm assuming it's a variable. A variable can also be used as a parameter. Hence why I put radius in as a parameter. Put them all together and I just return that. Hence giving us our circumference.
So if I wanted to print that answer, I'm trying to do it over here. How would I do that?
To print the answer, are you trying to see an answer on the right-hand side?
Yeah.
So what do we use to see things on the right-hand side?
Console.log.
Yep. So we need to start with the
console.log. Do I do it
console.log.
within the function?
So we say console.log, and then we need to see what we want to print. What do we want to see print? What function?
Orbit circumference.
Orbit circumference. So we type in orbit circumference. Orbit circumference is a
function.
Function. So what symbols do we need on after orbit circumference?
Parentheses.
Parentheses. Very good. And then what goes in the parentheses?
Oh.
Radius.
Radius. So in this case, we'll just do 10. Let's see what we get there with 10. I'm going to run this. And our orbit technically in, I don't actually know what those are units would be, is I think kilometers, something like that. 62.83, lots of other numbers. So that's how we could see the result there if we just typed it in through the console, like just to kind of test it out.
So is 10 just an arbitrary number?
Yep.
Okay.
So let's see if it gives us any examples. Yeah, go ahead.
Do we have to round the figure?
It doesn't indicate anything about rounding. It doesn't tell us we need to round anything. So at this point, I'm going to say no.
Okay.
Yep. Yeah, rounding will only be necessary where it tells us. The only little outlier was that flooring that we did in the random generator, but we were given that expression. So any other questions about this stuff? All right. I'm going to keep on going. On to part B here. Define the mission duration function to take 3 parameters: the number of orbits completed, the orbit radius, the orbital speed. Set the duration radius to 2,000 kilometers. and the default orbital speed to 28,000 kilometers per hour. Okie dokie, fine then.
I think on
Let's go ahead and do that.
On part A, it does execute around.
Oh my gosh, it does. Thank you. Sorry. You should have yelled at me. Oh, I think that was Rena. I think you were the one telling me that. I apologize. You're absolutely right.
that's
Round the
fine.
circumference to yeah, I apologize. Round the circumference to an integer. Absolutely right. So math.round. Thank you so much. I apologize. I overlooked that. So what we do to round that is just do math.round. It should round it up to the nearest integer. We'll run that again. We should get 63. Oh, I don't have that anymore. Console.log. Orbital circumference of 10. It was 62 last time, so 0.8 should be 63. Here we go. Perfect. So now we are rounding. Again, apologies for that one. Absolutely correct. We were supposed to round. Awesome, awesome. Any other comments or questions about that one? All right. Then let's move on to mission duration. We're going to start creating the mission duration function. As always, we start with a keyword function and say mission duration. And we need to take in 3 parameters. The number of orbits completed. So num of orbits. No, sorry, the orbit radius. So orbit radius. And the orbital speed. Orbital speed. Thank you very much. Speed. Perfect. There we go. Open and close curly brackets there. I'm going to close this up just so, again, we have enough room here for everything. Move this over just a little bit. Perfect. All right. Set the default radius to 2,000 kilometers and the default orbital speed to 28,000 there. So what does that exactly mean? Set it by default. Well, in the case, so we've seen functions that we do not always have to pass in parameters into the function. What do I mean by that? If we look at orbital circumference, we could technically say orbital circumference, and I just want to do open and close parentheses. Technically, we can do this. It is very recommended not to do this, but JavaScript will try to be your friend and help you out here. But we always don't want JavaScript to help us out and be our friend because sometimes that can hurt us in the end. So for that, if we don't provide any, or if the user or the coder doesn't provide any parameter here, we want to be able to protect against that. We want to protect against JavaScript's loosey-goosey hold on that. How we do that is set a default. The default we want to set here is the radius to 2,000 kilometers. So how do we do that? It's say orbital radius equal 2,000. What we just did here is set a default parameter equal 2,000. It means that if nothing's passed in for orbital radius, then just assume 2,000 automatically. That's what's happening here. If undefined comes in as orbital radius, it will be automatically set to 2,000. So let's go and see this in action. We're going to console log orbital speed here, or excuse me, orbital radius. Right now, what I'm going to do is I'm going to call to this function. I'm going to call it right below it. I'm just going to do open and close parentheses. What I'm going to do is I'm going to see what is printed out here. It's going to print out the orbital radius. Let's see what it prints out. It prints out 2,000. Now what happens if I take away this equal 2,000? We'll run it again. It prints back undefined because nothing has been provided. Now, 1 second, I'm going to put 2,000 back here. We run it again. We're going to see 2,000 is there. And now I'm going to pass in another number. I'm going to pass in 900 or 9,000. I'm going to run this again. And now I see 9,000 is passed or written to our console log. So what we just saw or what we just witnessed is that if it is passed in as undefined orbital radius, then it will automatically be set to that default value, which in this case is 2,000. And that's what this line does. Any questions on that? That's one thing we really didn't cover too much in lecture.
So is this like we are reassigning another value to the orbit radius?
You are only assigning a default value.
Okay.
What that means is that if nothing is provided, then something is provided.
Okay.
So if nothing is provided, the default value, which is 2,000 here, is automatically assigned to orbit radius.
Okay.
So think about this as almost like an airbag. If your user forgot to provide a parameter in there, this is your protection against it.
Oh,
So
thanks,
how
guys.
does it know what the 1 and 9,000 is referring to? Because there's 3 different things in there. There's number of orbits, orbit radius, and orbital speed.
If I say 1, 2, and 3 here, how would you assume, where would you assume 1 goes inside of here?
Number of orbits.
orbits.
Yeah.
Very good. And for 2, it will go to orbit radius. For 3,
Radius.
it will go to orbital speed. It's all
Okay.
about placement. It's all about
Okay.
placement. In this one, this is specifically called a function or method's signature. It knows that if you place something right here, it will come into this slot. You place it in here, it'll go into this slot, and etc. for 3 into orbital speed. So it goes directly into that slot. It's all about placement. Great question. We haven't really explored that either. We're just assuming that it falls in the right places, but I promise you, when we do that, it will actually go to the correct location, depending on where it is with those commas. So if we run this again, if I run this right now, what will be my orbit radius?
2.
Very good. Yes, it will absolutely be 2. Awesome. Because we actually provided a parameter there.
Why is it only printing out orbit radius and not printing out everything else?
Because I only asked it to print out
console log
orbit
orbit
radius.
radius. Okay.
Yep. No worries. Yep, right there on line 14. Perfect. All right, let's keep going here. We need to set the default orbital speed to 28,000. How would I do that?
Same way we
Tell me.
did the radius equals 28,000.
Perfect. I go over here to orbital speed equal 28 and then 3 zeros. Perfect. Awesome. Awesome.
Why is orbital speed not blue?
Because Replit just wants you to be confused. There's
It's
no
like that
real
on
reason.
mine too.
Okay.
There's no real reason. Yeah, Replit is a beautiful online tool. It is not a true environment, so there are a lot of kinks to it. When we move to actual environments, you'll see everything more in sync. But yeah, that's just a Replit thing.
It got me confused too. Like when I first started learning these objects, like I thought I knew key is supposed to be only a string, but then because of these colors, I thought it could be an array.
Yeah. Sometimes it can be an error. Don't underestimate discoloration. But for this one, it looks like everything's correct. So it's just a little bit of a Replit thing. But first assume error, double check yourself, and then blame it on Replit.
Thanks.
The typical hierarchy. Yeah, absolutely.
No, it's always Replit's fault. That's
exactly
every single reason why I mess up. It's Replit's fault.
You know what? If you're having a bad Monday or a Thursday, just blame it on Replit. Just throw it under the bus. It's fine. Replit doesn't care. All right, let's keep on going here. So define mission duration function. I don't think it tells us exactly what we need to do here. It just tells us what the defaults are. So let's see what we need to do in the function. Calculate how long it will take our animals to complete a certain number of orbits. Time equals distance divided by speed. Round the answer to 2 decimal places, then return the result. Return the result. All right. This is always the one. Okay. So calculate how long our animals will take to complete a certain number of orbits. Time equals distance divided by speed. So distance is our orbit circumference. So what we want to do is say const distance equals orbit circumference. We pass in the radius. Our radius is provided to us, luckily, so we say orbit radius. So what's going through my head, sorry here, this is also the part that I messed up on, so I'm making sure I don't mess up on this. But we need 2 things, distance and time. Or sorry, distance and speed. It's given to us there. Time equals distance divided by speed. We are given speed in the parameters. I don't need to worry about speed. It's the distance. Where do I get distance from? Distance has to deal with how large our circumference is. So how large our radius is creates our circumference. But this is only for 1 orbit. What if we have multiple orbits? Well, look, we have number of orbits. So what do we need to do with number of orbits to get our full distance?
Multiply it.
Multiply it. Absolutely right. Yeah, we're back in physics class here. So yes, we do num of orbits here multiplied by that orbit circumference. So now we have distance. We already have time, which again is, or sorry, we already have speed. So we're good there. So now we need to calculate time. So we need to say const time equals distance. Speed. Did that just go out? Okay, good. Distance divided by orbital speed. Right. Distance divided by orbital speed. So that is our time, and then we technically return time here. What we can do here is also say math.round. We need to round to the nearest 2 decimal places. All right, this one is a fun one. How do we exactly round to 2 decimal places? Well, for this one, rounding, remember, takes away the integers. Or sorry, it will round it to the most whole integer number. So what we need to do is actually take this inner portion here, multiply it by 100 for 2 decimal places, and then after it is rounded, divide it back by 100. So what we just did is we multiplied by 100, then rounded it, then divided it by 100 again to give it 2 decimal places back. And then we return time. If you wanted to also simplify this expression, you could just take this whole thing and return that instead. Just like that. So that is how we could write that. So what I'm going to see is mission duration. I want to see if they give us an example just so we can make sure we're good there. For example, default radius and speed, 5 orbits will take 2.24 hours. Let's see if that works. So they said number of, how many speed? 5 orbits, right? Let's see, mission duration. I'm going to console log it. So it said that the answer should be 2.24. Let's see if I'm correct on that. Oh, I mean, of course it's right. Yeah, of course. Wasn't worried at all. All right, 2.24, that looks correct there. I'm gonna also remove this console log up here on line 14. That's why we're getting that 2000 above it. I'm gonna run that. 2.24, we're good there. So we have completed that function. Any questions on that one? Ooh, excuse me. I'm hearing a lot of silence. I'm hoping that's a good sign.
All of my maths were lowercase. I'm fixing it.
No worries.
I found out there is one change all occurrences. So if you hit that, it will change it for you. Like suppose you want to, like in line number 13, you want to change mission duration to just mission. Then you highlight it, right click it, and select change all occurrences, and then it will change it for you.
Oh, very cool. Okay.
Yeah. Just in case, yeah.
Yeah, awesome, awesome. Cool.
Kind of a find and replace.
All right, any other questions? Anything else? All right, and we're gonna keep on trekking on here. We are on to part D here, which is the fun thing, printing this little message here. So what I'm gonna do is gonna go ahead and copy this message, bring it over to our replit. This is our string literal. We did this in the last one, so it's not gonna take too much time. I'm gonna paste the message there. I'm gonna say const message equals, we'll travel about, hours to complete. Okay, so what I'm gonna do is that, how do we do that? How many hours can we complete? Okay, so what we're gonna do here is say const radius. No, we don't have to do that. What we're gonna do is start creating our template literal. So we do that back tick, and we say the mission will travel $, curly bracket. And what I'm gonna do is just actually call the function within here, because why not? Well, travel, and we need a distance here. So that is the orbit circumference. Orbit circumference, we're gonna say our radius for this example will be just 5. km around the planet. And yes, you can call a function within our temporal literal. We have not done that necessarily before in any of our reviews, but you can definitely do that. So the kilometers around the planet, and it will take $, curly brackets, and then our time one is mission duration. Say 1. Okay, how many orbit? Okay, so we said 5 for the radius, and then orbital speed will just keep normal. Close that curly bracket. Hours to complete. There we go. Yeah, let's run a speed. Why not? I'll say we're going like 75,000. Go super fast. All right, let's go and see that we have our message there. So now we need to actually console log our message. And then we go and run this. The mission will travel 31 kilometers around the planet. Oh, it's a little squished there. There you go. It will take 0 hours to complete. Oh, probably because I didn't give it enough. Fine, fine, fine. All right. We're going to say we make it at like 1,000 orbits around there. We're going to go 5,000 is our radius. We'll give it actually something that's a reasonable. There we go. Run that. There we go. 31,000 kilometers around the planet will take 418 hours to complete. So there we go. Now we actually give it real information. So we're actually able to see some decent results. So that is what we get from that. Any questions on any of it? Our message, why we put the function inside the temporal literal, anything? Anything at all? How's everybody feeling about this so far?
Good. I'm just
Pretty
getting
good seeing you do it.
stupid reference errors.
All right. I'm getting mixed reviews there, but good, good, good. It sounds like mostly positive. So awesome. All right, let's go ahead and keep on finishing this up. Number 2, time for the, oh my God, execution there. Code an oxygen expended function to accomplish the following. A, the function should take a candidate object as a parameter and not the crew array. Okay. Okay. Code next should expand a function to accomplish the following, and we have a bunch of stuff. So what we're going to do is start writing the function for the oxygen expended. So we're going to go over here to Replit, come down here. Okay, copy and paste your random and there. Okay, here, this one we need. So function, as always, because we had to start with the keyword function. NCTION function oxygen expended. And I haven't heard about any parameters yet, so I'm just going to go ahead and put an empty parentheses there and then open and close curly brackets. Awesome, awesome. All right, let's go back and see what we need to do here. A, the function should take a candidate object as a parameter, not the crew array. All right, so it should just take a candidate in as the parameter. So that's what I'm going to do. So I'm going to say candidate here in the parameters. That's what it said to do. That's what we're going to do. All right. Next, the spacewalk will last 3 orbits around the Earth. Use the mission duration to calculate how many hours the spacewalk will take. All right. So that's what we're going to do here. We'll take 3 orbits around the Earth. Use mission duration to calculate how many hours the spacewalk will take. So I'm going to say const time equals mission duration. And right now I'm going to keep everything default because I haven't seen anything else that suggests different. So it says, we just say 3. It said 3 orbits around the Earth. Perfect. For mission duration. So that's our time. We're going to keep these again default. The defaults again are 2028, or sorry, yeah, 2028,000. And that will calculate our time there. So that is what we did for that. So we have the time for the spacewalk. What do we need to do next? Use the candidate's O2 used method to calculate how much oxygen, O2, they consume during the spacewalks. Round the answer to 3 decimal places. All right. So let's go ahead and explore what that used O2 method is. We come down here and we see it's a function. All right, perfect. It's a function that has, it's different from for every single candidate. That's kind of neat. So let's go ahead and do that. What it needs is that it actually uses a parameter here called hours. So it actually needs a parameter to do this anonymous method. So that's what we're gonna do. Every candidate looks like they have an O2 used property, aka a function for its value. So we're good there. So what I can do is I can say, hey, I want to call the candidate, whoever's passed in, as my parameter. And I can call to that property, that function, that used O2. And so how do I do that on a object there to get that function? What do I need to do?
Dot notation.
Object dot.
Very good, the dot notation. And then what am I going to be using? What did it say in the directions? What property
O2
name?
used.
O2 used. Awesome job. O2 used, and it is a function. So what is always at the end of every function if we're calling it?
Parentheses.
Very good. And it said in this function, again, that we need hours provided. Luckily, we have those hours calculated here in our time variable. So I place time inside of those parentheses. Now we're able to save the O2 used. Awesome. So we're able to calculate that individually to whatever candidates passed in through this parameter. So let's go ahead and actually see this in action. Console.log. What I'm going to do is console log the time, comma, O2 used. Remember, you can use commas inside your console log to print two things out on one line. And then I'm going to call it. I can't call it until a candidate is actually created, so I need to call it actually down here. What I want to do is, oh, what was that? I already forgot the name. Oxygen expended. Do oxygen expended. And I'm going to just choose candidate A there just for ease of use. Perfect. So we're going to go ahead and run this and see what happens. So we already saw this from the previous example. Down here's what we actually care about: 1.35 and 0.04725, etc. So it looks like we are getting results printed back out. So awesome. That's what we want to see. What we're looking for here is making sure that it doesn't say like nan, it doesn't say undefined, things of that nature. We're getting two numbers here, so it's looking good so far. So I'll come back up here to oxygen expended. Any questions about this before we keep on going? All right, let's keep going then. So we did B and C, and we're on to D here. Return the string, blank will perform the spacewalk, which will ask blank, blank, blank. All right, let's go ahead and get that. We've already done this before. No need to read it all the way out loud. Bring this over here. But where do we need to actually put that? That's a good question. Return the string. Okay, we got to return it. So now we're going to be returning a temperate literal. So we use those backticks. I'm going to place my comment up here, but we actually need to write out. So blank. So what we need is the name of the candidate, because it's saying, okay, who is doing this? So we say candidate dot name. Remember, we're using that dot notation to pull out the name property from the candidate object. The candidate object being right here. Awesome. Let's keep writing the rest of the sentence. Will perform the spacewalk, which will last. And then we have to include the hours. The hours there is under time. So we say, I want to include time here, my time variable, hours, and require the O2 used, which apparently is in kilograms. Interesting. O2 used, kilograms of oxygen. Period. Perfect. So there we go. There we go. We are returning that string back from the function. So let's come down here and actually see that in action. We're going to console log what is returned from the oxygen expended function. I'm also, while I'm up here, I'm going to remove this console log that we had there before. All right, drum roll, please. Let's go ahead and see this, run it. And what I'm actually going to do here is comment out this message just so we can see the original there. So I commented out the original examples console log so we can actually see the new message. So Gordon will perform the spacewalk, which will last, wrap it with your search thing, 1.35 hours and require 0.47 or 0472 04725, etc. kilograms of oxygen. Oh, but that is one thing we needed. That's why it doesn't look so pretty. We need to, that's why we always copy this stuff. We need to round to 3 decimal places. So that's one thing I'm missing here. So we're going to go under here, paste that comment. That's why we keep those here, so I can actually read the stuff to 3 decimal places. So what we need to do here is we say math.round, and to do 3 decimal places, we multiply the answer by 1,000. And then after that, we divide by 1,000. Again, we need to multiply by 1,000, round to the nearest integer, and then divide by 1,000 to make it back to a decimal. It's kind of just adding some padding, rounding it, and then taking away that padding again, and making it back into a decimal. So that's what we have here. Now we round it again, and we're actually getting a more pretty looking decimal, 0.047. So that was the one little mishap I had here on the oxygen expended. We're just about to do that rounding. For some reason, I just don't want to do rounding tonight. So that is how we do that.
Did it work? It looks like you might be missing. Never mind, I found it, the missing parentheses.
No worries. Let me double check here. Yeah, I've got parentheses right here, right after the round. That's awesome. All right. Any other questions on this?
Could you scroll down to the bottom real quick?
Yeah, absolutely. All right. Any final questions, anyone? Going once, going twice. All right.
We got it. I'm sorry. I was trying to get to my mute button.
What's up?
For mine, when I put console log oxygen expended candidate A, for the function, I have it's saying undefined basically. I guess my parameter for oxygen expended is undefined, but it's looking like I have everything for the function oxygen expended the same. Because the candidate portion is what I'm not seeing. I'm sorry.
So we have, okay, so oxygen expended has a parameter called candidate here. So it depends on where the undefined is coming in at. So we need to make sure we're passing something in here for the candidate. So if we scroll down on this code here, right here for oxygen expended, we're passing in the candidate A. So I just want to make sure you're doing that as well.
Let me double check. Yep, I'm passing in candidate A.
Yep, so up here then, we just got to make sure that your candidate is being used. So yeah, you're gonna have to show me your code then if you're getting undefined, because I'd have to know more detail about specifically where you're getting the undefined at.
Oh, I didn't have my return put in just yet.
Oh, gotcha, okay.
Thanks.
Absolutely.
Why do you close the math.round after the multiplication and not the division?
Because if we just multiply and divide by 1,000, if I
just cancels it out.
Yeah, 1,000 divided by 1,000 is just 1. Hence, we're just gonna get that large. Well, actually, we'll get 0 at this point because of mathematical operations.
That's the problem I was getting during the group breakout thing.
No worries. Yeah, we have to round everything and then we divide. Is the step-by-step process there? Good question. Awesome. Anything else? Anything else at all? All right. And we're going to keep on going here. We return the string, and then finally we are on to part E here. We should not restrict our mission to the default values for orbital radius and orbital speed. Refactor oxygen expended to accept values for these items. Remember to include the values in mission duration call. All right, let's go and do that. Basically what we're doing is expanding our minds here for the oxygen expended. We need to include 2 more parameters so we can actually more customize this function to any situation our application might find itself in. So to do this, we need to include the 2 extra things, 2 extra parameters. I want to make sure I get that. I believe it is the orbital radius and the orbital speed. So that's what I'm going to go ahead and do here. We need to include parameters for these 2 things. So what I do is I do comma, and just call it, I want to call it orbital radius and orbital speed. Cool. All right, orbital radius and orbital speed. We included parameters here. So our next immediate question to ourselves is, all right, where am I going to use this thing at? The answer to that is the function that wants it the most. That function being mission duration. Orbital radius wants to be included inside of this function call. So we say orbital radius here, and then orbital speed is also wanted inside of this one. So we are able to include, why does that look really bad? I copied the whole line, there we go. And then we include orbital speed there. So now we're able to actually include this inside of our mission duration, calculate our time, and then use it wherever else it's called. So time is used down here on line 36 as well. So now we're able to customize this method to basically create any kind of time we want. Again, for just whatever situation this function is going to find itself in. So let's go ahead and just include that inside the parameters. So I want now for oxygen expended, I want my candidate to see what happened if my orbital radius would be maybe again at 7,000 kilometers, and then orbital speed is going to be 30,000. I run this, and we see that our message is updated to that. So awesome. Again, we're able now to customize that function. That's the power of those parameters there, where you can include more information to make it more, basically make it more appropriate to how we need to actually use the function itself. That is why we absolutely love parameters in there. But again, if we don't want to use those parameters, we can always, or we don't see maybe our user always including all of the parameters, we can always put those default values in there by using the equal sign. Exactly what we saw up here in our mission duration, those equal signs. Those are our default values for our parameters. Again, if undefined is provided. But cool, that was E. Any questions about that? I'll go ahead and scroll back down here. All right. Then in that case, we are officially done with, what is this one? 12.8.2. So there we go. E is finished. This studio is technically finished to this point. So as always, it is 9:30. Feel free to log off. It will always be recorded, but we will be continuing on through the bonus missions to 12.8.3 here in just a moment. Any final questions before we continue on?
No, I'm
All
going to
right.
log off, but thank you, Kyle.
Absolutely, Annie. Have a great night.
You too.
Yeah, thank you very much, Kyle.
Yeah, absolutely, guys. Real quick for everyone that's going to be hanging around, feel free. I need to just run just real quick off camera, and I will be right back. So get some more coffee, get some more water. I'll be back momentarily. All right. Fantastic. 21 friends remain. Let's go ahead and do this. I apologize for tonight. I would usually be more, I don't know, my mind is gone and I have an absolutely pounding headache. So I apologize. But we're going to go ahead and get through this thing, through this whole studio review. We're going to have fun with it. We're going to have fun. We're having fun. Y'all ready to do this? think that was a yes. I heard a Windows tone, so we're gonna do this. All right, let's go ahead and get started here. So we are at 12.8.3 bonus mission, starting with 12.8.3.1, conserve O2. Instead of randomly selecting a crew member for the spacewalk, have your program select the animal with the smallest oxygen consumption. All right, interesting. Let's go ahead and do this. So we are going to go into this bonus mission. So actually, one thing we didn't really do too much is select a random crew member to be essentially sent for the spacewalk. So that is one thing. Let's go ahead and bring that over here. So let's go to our original. There we go. We have to go to our original replit from part 1. And what I did is I copied the select random entry function here. I'm going to bring it back over to this other replit, and I'm going to paste it where it said it wanted me to paste it, which is up here. There we go. So there we go. That's what we needed. So if we ever wanted to come down here and actually select a random candidate here to do this, what we do is say select random entry, I believe it was, and then we say animals or crew. Is it entry or? Yeah, I had it right. Cool. So that's how we would actually edit that to do a random crew member there. So we run this, let's see. So Jonesy will be performing the spacewalk, which will require that set amount. So if you wanted to see the ending of that, if we wanted to put in that randomizer, this is one way we could have done it. So any questions on that before we actually hop into this bonus mission? All right, let's go and hop into it. All right, on to 12.8.3.1. For this one, I'm going to go ahead and copy what I just said already, so we can bring it over here, and we're going to go ahead and start doing this. Instead of randomly selecting the crew member, we have to have your program select the animal with the smallest oxygen consumption. So for this one, now we have to think about this. All right, we need to find the crew member that has the lowest oxygen consumption. We need to go one by one to each candidate and ask, how much oxygen are you going to consume at this set amount of time? The person with the lowest amount of consumption is our winner. So what tool do you all feel that we're going to be using to approach this problem?
It'd be like the math.min for the min.
Well, if we did a math.min, we'd have to have a set of values to find the minimum amount. So what would we have to use to find those values of those what tool would we have to use to find all those values to find the minimum of?
Would you use like a for loop and then
Yeah,
reference the values?
Technically, if we want to do a math.min, we could do that. But in the end, we will still need to do a for loop over each of our candidates to get those oxygen consumption values. So in the end, what tool we're actually going to be using here is a for loop. So that's what we're going to be using here. But instead of the mins, though, what I'm going to do is something a little different. What I'm going to do is I'm going to create a variable, say is let lowest of 2 candidates equal undefined. Or in this case, as we saw before, we can actually do crew of 0. And then after this, we're going to do a for loop. So say for let I equals 0, I less than crew.length, I plus plus. Now what I need to do is actually loop through each time and see who has the lowest amount of consumption. Now, one thing I want to talk to you about is that the crew array for this example, for some reason, doesn't have all the candidates inside of it. So what I'm going to do is actually include all of them. Just for our bonus missions here. And then we need F as well. All right, there we go. Now our crew has all of our candidates or animals inside of it, so we are good there. So now we can actually start looping through all of our crews, knowing that all of our candidates are inside of it. So what I want to do now is I want to ask, is this the lowest? Actually, I can put that out. We'll do it later. I can ask if this is the lowest candidate O2 that I've seen. But before I actually can ask that question, I'm building this in my mind right now, is I actually need to get the O2 consumption first solved for. So that's what I'm going to do here. For the for loop, I need to go ahead and ask for the O2 consumption of that particular candidate at index I. So I say const O2 consumed equals crew at I dot used, what is it? Oh, O2 used. O2 used, and then we need to pass in our hours here. In this case, we just need to choose a static number or one that does not change to plug into our parameters, one to match all of our candidates against. In this case, I'm just going to put 1. So I say O2 used for 1. So O2 consumption. So now this is now where I need to ask, okay, is this the lowest O2 consumption I've seen ever? So I need to do an if statement. So is O2 consumed less than, but I have nothing to compare to. This is the problem right here. I need to ask, is this the lowest O2 consumption I've ever seen? But I need a variable there to remember the lowest O2 consumption I've ever seen. So not only do I need to declare a lowest O2 candidate, but I also need to declare a number. Let lowest O2 consumption equal, I'm going to put undefined here. There we go. Lowest O2 as defined. And I'm actually going to mark both these as undefined, because that's just basically my practice there. So now I actually have something to compare to, lowest O2 consumption. So if O2 consumed, which is the one calculated here on line 100, is less than the lowest O2 consumption I've ever seen, then I need to say my lowest O2 consumption is now the O2 consumed from whatever candidate I'm looking at index I. And now my lowest O2 candidate is crew at I, whatever index we're looking at. Now, one thing we got to pause here and talk about is that, okay, if we are in our first loop, what is the value of lowest O2 consumption? Who can tell me what our value is at index 0 at this case? Where's our value going to be here? Anybody got a guess? Promise, you won't even have to do any math. If we were the program, we start at line 97, we go down here, for loop is 0, what is lowest O2 consumption at this point right here?
Undefined, nothing.
Very good, it is undefined,
Defined,
absolutely
yeah.
correct. It is undefined. It's undefined. It's not even a number yet. Can we compare a number to undefined? Can we ask if 0 is less than undefined? The answer to this one is no, we cannot. So what we need to do is add an extra conditional in here to protect against this. So if we say lowest O2 consumption equals undefined, or our O2 consumed is less than our lowest O2 consumed, then update both of these variables. So what this is basically saying on our first loop, just set that to the lowest O2 we've ever seen. So that's what that little additional conditional here is doing. So we're just setting it in there. So this right here, this loop with this conditional will help us find our lowest O2 candidate. And by doing this, we're going to go ahead and console log it. We're going to see who our lowest O2 candidate is. All right, let's go and run this. And survey says, I need another Tylenol. And Replit just knows it's late. I'm going to refresh this. Run this again. What line is that on? It's on line 101. Let's go down to 101. We've already typed 100 lines of code. Oh my gosh. 101. See, I can't spell consumption at all. There we go. Let's run that again. Wow, I cannot spell anything today. Candidate. It was on line, what, 1? Okay, there we go. Lowest empty candidate. There we go. Let's try this again. Perfect. So it's a misspellings there. I absolutely apologize. So this is still nothing that's changed on the loop, just me fixing my mistakes there. We console log our lowest O2 candidate. It looks like it's Petey here, the tortoise, good old tortoise. So for this one, it looks like, I don't even know what his O2 consumption was. Let's go and see what his consumption was. Not that it really matters that much, but it's always nice to check out some numbers. It looks like his consumption was at 0.1. So it totally makes sense of why this good old tortoise is definitely going to space. Low O2 consumption there. So any questions about this one right here?
Can you explain the undefined part one more time, Kyle?
Yeah.
I always thought undefined is like, it's like null. Can you please explain that, like what's undefined?
So undefined So undefined in this context means nothing. Undefined is like a black hole. It is nothing. Null is the same thing. Null and undefined are very, very, very similar.
Mm-hmm.
Undefined means nothing. It's JavaScript's default to say, you gave me nothing. But nothing needs to be represented in coding. And undefined is how we do that. It's basically how we say we have nothing.
Thank you.
So, yeah, absolutely. Good question there. All right. Any other questions on this? All right. Let's keep going. On to 12.8.3.2, fuel required for launch. To access this code for the bonus mission, let's go to the Replit. Oh my gosh, they are just getting us tonight. This was like I said, it was a fun studio, but I forgot how exactly fun it is. Little bit more here. Everybody staying awake out there? I'm gonna just fall asleep. I'm gonna just fall asleep on this desk. Good, I see some thumbs up, thank you. All right. Let's keep going. All 18 of you, oh my gosh, you all are doing fantastic out there. We're almost done. We're almost done. Just 4 more steps to go. All right, let's keep going here. A general rule of thumb states that, a general rule of thumb states that it takes about 9 to 10 kilograms of rocket fuel to lift 1 kilogram of mass into low Earth orbit, LEO. For our mission, we will assume a value of a 9.5 kilogram to calculate how much fuel we need to launch our crew into space. Okay, let me get that. For our mission, we will assume a value of. Oh, okay. I see what it says. Okay, because it's between 9 and 10 kilograms, so we're going to go with 9.5. Got it. A-okay with that. Let's do this. All right. 1, write a crew mass function that returns the total mass of selected crew members. Blah, 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 blah. Okay, let's go ahead and pause that before I even just read that through, just because there's so much stuff to do on this one. So code the crew mass function here. I'm going to go and comment exactly what it wanted to see. I'm going to move this stuff over just so we have a bigger space to play with here. And let's go ahead and do this. Start writing our function for crew mass. We say function and crew mass. And then in here, it returns the total mass of the selected crew members round to 1 decimal place. Okay, it doesn't tell us any of the parameters though. That's what I'm worried about. So, I can just assume it wants to take in an array of crew members. I'm assuming, but I don't like to assume too much. So, okay, well, it really just wants us to assume. That's what I guess a bonus mission number 2 wants us to do. So I'm gonna assume it wants us to take in a crew array here, because it needs us to get the total mass of the selected crew. So that crew array is going to be that selected crew. What I need to do now is I need to actually, and what I can do here is, 1, I can do a for loop, and we just add all of that together. So what it would be is I would say const total mass equals 0. Oh, I can't do that because I'm going to be updating total mass every time I add. Say for let I equal 0, I less than crew array dot length I plus plus, and then total mass plus equals crew array dot, what is it, mass and we return total mass. Now, pop quiz out there to all you very awake people. Instead of a for loop, this will absolutely work here if we wanted to. We would just pass net crew mass. Let's go ahead and just take a quick look. So this is, we're going to say this is our selected crew right here. What we're going to do is say console.log crew mass, and we're going to pass in our crew here. This should definitely work. Let's go and run this just a minute. Oh, you would. 0 total mass plus 0 cross. Mass is 90.1. What? Not a number. Lies. Log. Oh, my. This is what happens. This is what happens when you code a 10. Bad things happen. Every biggest engineering mistake happens after 10 with a coder and a keyboard in hand. All right, because I don't put index there.
Yeah.
That's how you crash a Tesla on autopilot right there, kids. All right, here we go. It's because I was trying to get mass out of an array. Mass doesn't exist in an array. That's not a property in there. I need to call it to the index, one of the objects inside the array. All right. We are actually getting our mass back. Now back to my original question. Instead of doing this giant for loop, who, for 5 extra Kyle Brownie points, can tell me another type of function or something else we can put in here to reduce this amount of code? Anybody got an idea?
While?
No. Technically, we wouldn't want to do a while here. We want to do a while. We actually want to try to get away from loops in some certain aspect.
Okay.
What we could also do is we can do crew array dot the reduce. Reduce. So its previous value. So it's technically called the accumulator in the current value. I forgot what the actual current value is actually true. Is current. Oh, that's when I can't. Yeah, we have to radius function. There we go. So what we do here is we say ACC plus equals cur dot mass. I think we'll get the same thing. I always got to practice my reducer stuff. Ah, no. Oh, I got to return it. I'm gonna be too tired for this one. Let's see if I can actually get my reducer out there. Yeah, get my reducer patterns. I'm really bad at reduce. I really am. I was like, I never use it. So I gotta get my practice in here. Previous value. Yeah, that's what I was doing. So why were you yelling at me? I'm doing it. No, because it's an array of objects. It's fine. Right? Yeah. Yeah. You're just like yell at JavaScript like, no, you're wrong. Like, I'm not wrong. ECC and then current. We're gonna see what this thing's thinking. If I can't get this in the next 5 seconds, I'm out of here. Yeah. Oh. Incorrect. Oh my gosh. Okay, whatever. I'll come back to my reducer later. This is why I need to practice. I can do, just do an ES6. No one be mad that I'm doing this. I really need to see if I'm. Yeah, we're coming back to it. We'll be back to you later. I'll be back. Because we all want to go to bed, right? We'll do reducers later. There's plenty of time in JavaScript to do some more reducers. Yeah, so one thing, if you ever want to know my soft spot, it is reducers. Cannot, it's like a summation, and I'm just like, nope, too close to math. No, thank you. All right, we did our crew mass function there. Let's continue on here. What we are on to next, the mass of the uncrewed rocket plus the fuel and other supplies is 75,000 kilograms. Create a fuel required function to combine the rocket crew masses. Calculate the return amount of the fuel needed to reach low Earth orbit. So I'm going to go and copy that, bring that over here. You paste all that stuff in there. Okay, so we need to start writing the function, fuel required. So I say function fuel required, and then no parameters just yet. That's the uncrewed. Okay, so we said from our stuff here, it takes 9.5 kilograms. So every 9.5 kilograms, it takes 1 kilogram of fuel. No, wait, other way around. Yeah, no. 9.5 kilograms of weight takes 1 kilogram of fuel to get into space. So what that means is that we need to do our, if we do our weight, whatever, or our mass, excuse me, our mass divided by 9.5 times 1 will give us our fuel. But we know anything times 1 is just the same exact number, so we actually don't need the multiplier by 1. So we can reduce it to that. So what we can say is, so we say const weight or mass right now is 75,000 kilograms. It's given to us in the description there. So 75,000. And then we need to return, or so our const fuel technically would be our mass divided by 9.5. Then we return the fuel, just like that. Of course, we can always simplify if we wanted to by just returning mass divided by 9.5. But I feel like we're going to expand on this just a little bit, so I'm going to keep it like this, just for the time being. So any questions on what I just did here? Anything that anybody wants to point out?
Oh, Kyle, I think it says it's like 9 to 10 kilogram of rocket fuel to lift 1 kilogram of mass.
Oh, thank you. I knew I had it backwards. It totally is. I was like, that doesn't make sense, right?
Yeah.
It's way too cost effective. You're absolutely right. So what I need to do is multiply that mass by 9.5. So technically what you do is divide it by 1 and then multiply it by 9.5. So instead, we don't need to divide it by 1 because it's just the same exact mass. We just multiply it by 9.5. Does that look a little bit better? Awesome. All right, let's go ahead and do our field required down here just for a moment. Let's see what we have. Run that, and it looks like it takes 712,500 things of fuel. I don't actually remember what the units were for that, but that is how much it takes to get into Leo there, from what I am seeing here. So on to number 3. Any questions on number 2? Anything else that anybody wants to talk about there on number 2? All right, on to number 3 then. We only got 2 more left, everyone. Last bit, let's get to it. Our launch requires a safety margin for the fuel level, especially if the crew member are cute and fuzzy. Add an extra 200 kilograms of fuel for each dog or cat on board, but only an extra 100 kilograms for other species. Update fuel required to account for this. Then round for the final, okay, then round up to the nearest integer. Okay, this is quite a bit here. So, oh, and I did forget something. I knew it was like, this is way too simple here. And the crew masses. So we need to actually include the crew masses inside of this. So we're going back here to part B real quick. For the fuel required, we actually need to include the crew mass. In order to include the crew mass, we need to know who the crew is. So we say we need the crew array in here as well for the fuel required. Then down here, we say const crew mass equals crew mass crew array. What we're going to do now is we take that crew mass, we add it to, again, I'm just doing this just to kind of tabulate up, just divide it up for our own vision here. We can always simplify this into one line if we wanted to. I'm going to call this total mass now. Total mass, and now we should be a lot better here. So what I'm going to do in crew fuel required, I'm actually, I'm going to put crew in there so we actually have a crew to calculate. So now I run that. Nationalization error, let's go ahead and see that. That is on line 16. I go up to here to line 16. Oh, because I named a variable after a function name, so I don't want to actually do that. I'm going to call it crew mass kg. Everything has to stay unique, including that. Try that again. And now we are actually running properly. So good. All right, sorry about that. That was part B. Let's go ahead and finish up that part C. What it's asking us to do is coming over here. We're going to put this down a few. Perfect. Especially the crew members have found lazy. Add an extra 200 kilograms if for the fuel, if for each dog or cat on board, but only 100 kilograms for other species. So that's what we're going to go ahead and do. So what I need to do is update my total mass while I'm going through our crew array and checking for these species. So I'm going to be updating my total mass. I'm actually going to have to change this from a const to a let so I can actually update as we go through. So what I'm going to need to do is loop through our crew array. So if I'm going to be looping through an array, I need to do a for loop. So I say for let I equals 0, I less than crew array dot length, and I plus plus here. Now what I need to do is check to see if it's a dog or a cat. If I go up here to our candidates, I see that the species right now is ALF, but I need to check if it's a dog or a cat. If it is, then I update my total mass to be as such with a 200 extra kilograms there. So if my crew array of I dot species equals dog, or again, we have to ask a question, is it a dog or a cat? I said or in that sentence, so I say the dog, which I'm going to copy this, or cat, and my total mass plus equals just some 200 for that operator. So with a dog or a cat, add 200. Ooh, you know what? I'm doing this wrong. See, guys, I am so sorry. We need to update our fuel, not our mass itself. So we actually need to update the fuel, not the total mass. So I can change this back to a const here. And down here, I'm going to be updating our fuel. It's because we're updating that padding for the fuel itself. So I'm going to say fuel is actually going to be plus 200 if it's a dog or a cat. Now remember, it says a dog or cat extra 200, but anything else is 100 kilograms. So if I say, and that means otherwise, add 100 there. So I say fuel plus equals 100. There we go. So we added that extra padding on there. So now we go ahead and run this, and we see that we get a couple extra little paddings there on our fuel required. So any questions about that one? So what we did was we included a conditional in there to check the species of the object, see if it's a dog or a cat. Anything else? All right, last one, everyone. Last bit here, print out that message, of course, and fill in the blanks with the calculated amounts. Let's go ahead and do that. We're gonna come down here. Oh, and let's go see if we have to return this. Nope, we just gotta print that out. So we're gonna come down here. What we're gonna do, it says const fuel equals const message backtick, paste it, equal, and then I'm going to remove just the extra stuff. Just like that. There we go. The mission has a launch mass of $, crew mass. I type in crew there, and requires $, fuel, because I'm calculating that over here. I could always just throw the method into there if I wanted to. I just have the variable right now there, so I'm just utilizing it. Simplify it however you see fit. Finally, we console log the message. We run this, and we see the mission has a launch mass of 53.2 kilograms and requires 713,405.4 kilograms of fuel. So there we go. That is our message out there. Come back here. That looks like 4 is it. That is all we got, and that's all she wrote today for launch code. Fun stuff there for bonus missions. I'll go back here to the code for just a moment. Any final questions about what we just went through? Anything at all? All right, friends, then.
Kyle,
Oh, Hannah, yep.
If I'm not able to like finish all of the parts of the studio, I still could just submit it, right? Like it's not
Yeah,
like
absolutely.
graded on.
This one is not. No, you're more than welcome to just submit it, and you can always come back to it later. Again, these videos are out there tomorrow morning if you want to go through it again. But
Yes,
no,
yes.
as long as it's well attempted, you're all okay.
Thanks,
Yeah,
Kyle.
if you ever have any questions about if it's attempted or not, feel free to reach out to Clark, and he'll definitely sum anything up. Yep.
All right.
Yeah, no, all good. No, cool. All right, everyone. It is 10 o'clock. We have been at this for 2 hours. Thank you all so much for sticking around. We learned a lot there. Oh, that was a doozy of a studio. I just always remember this one being a super, super long one. So hope you at least all had a little bit of fun. But I am about to log off here. So any final questions here before I see you all in about a week?
Thank you, Kyle.
Thank you.
Absolutely, Hannah.
Thank you.
Absolutely, everyone. For sure.
Have a good
All right.
one.
Have a good trip.
You all too. Thanks, everybody. I'm gonna stop recording.